Here's the application of the Pythagorean theorem to a right triangle. So what I have here is a right triangle, which means that this one corner right here is at 90 degrees, okay? And it's labeled here as angle A, angle B, and angle C. And the opposite side is side A. The opposite side to angle B is side B. And the opposite side to the right angle here, C, is C or H. This is also considered the hypotenuse, all right? So if we wanted to take a look at this, we can see that this angle here is smaller than this angle here, which is smaller than the angle here that's 90 degrees, okay? So that's the smallest angle and that's the largest angle. And we know that these have to equal 180 degrees. So we take a look at this example here. We have our right angle. We know that it is 90 degrees right here. And then we have our smallest angle, which is 30 degrees, which would be here. And then we would have the other angle, angle B here, which would be 60 degrees. And we know that these have to add up to 180 degrees. So if you took 90 degrees plus 60 degrees plus 30 degrees, well, you do get 180 degrees. So this triangle is kind of checking out so far. Now, the lengths of the opposite sides, well, let's take a look at that and see if that makes sense. So the smaller the angle, the smaller the side that you're going to get here. So if this gets smaller, 25, 20, 15, well, A will get smaller and smaller and smaller. Okay, and if this gets larger, this side gets larger, bigger and bigger and bigger. So if we take a look at A right here, we have side A, which is the opposite here, designated by small a. This is equal to 6 units, all right? And those units could be inches, feet, whatever. And B right here is equal to 8 units. So that's the angle opposite of angle B is side B here. This is 8 units. And then the side C, which is the hypotenuse here, is equal to 10 units. So let's see if that makes sense, because you can't just arbitrarily throw numbers on here. They actually have to match up and meet the requirements of the Pythagorean theorem. So we have a squared, according to this, plus b squared equals c squared or h squared. So let's try it. We have 6 squared plus b squared, which is 8. 8 squared equals to 10 squared. And those would have some units on them. So let's just check it. 6 squared. 6 times 6 is 36 plus 8 squared. 8 times 8 is 64. And 10 squared, 10 times 10 is 100. Well, if you add 64 and you get 36, you add them together, you get 100. So 100 does indeed equal 100. So these angles and these sides, lengths of sides here, do indeed add up, and they validate the Pythagorean theorem here for an example right triangle.